Debugging really is more of an art form than a science. And what I mean by that is there's no foolproof, absolutely correct, 100%, 100% efficient way to debug code. Developers spend way more time debugging code than writing it. And if you include the parts about not just debugging, but testing it, more often than not, debugging could take twice as long as writing the actual code itself. And that's just because when you write the code, you're writing it for a very general use case, right? But when you debug the code, you're trying to make sure that you're really solving it for every scenario possible. And so debugging is an unavoidable part of programming. It doesn't mean that that you're bad or anyone's bad at programming. It just means that debugging is a process that everyone goes through. And like I said, while there's no perfect way to do it, we want to just kind of walk you through some of the debugging basics. I could probably help you out in the future. Unlike HTML, one of the really good things about JavaScript is that like when HTML, if you have an error in HTML, like we said earlier, the HTML will not tell you that there's an error. It'll just say, "Hey, I tried doing my best to render whatever you gave me, and this is what I got." JavaScript, on the other hand, will actually JavaScript, on the other hand, will actually come to you and say, "Hey, look, there was an error with your code, and I couldn't run it." And even better than that, they'll usually give you a lot of information, a lot of context around what the error is. And so, if you look at the screenshot on the right hand side here, this is an error that we came across when you're running JavaScript code. But more importantly, look at all the lines of text underneath it. So lines 3 and 4 are the same, but essentially they tell you what was the error that JavaScript saw, right? And that's pretty important to know. But even more important to know is that on lines 5, 6, and 7, those are actually what we call the stack trace of the error. A, a stack trace of the error doesn't just tell you what the error is; it actually tells you which lines of code were run for JavaScript to get to that error. Now, in most of the code that we've seen, where it's only 3, 4, 5 lines long, it's like not a big deal, right? You'll probably figure out where it is if you just look through the code. But imagine if you have a page of code that's more than 1,000 lines long, or if you have an application with multiple files, right? In all of these scenarios, if someone just says, "Hey, something in your code is broken," even if they tell you what's wrong, but they don't tell you how you got there, it can be kind of like looking for a needle in a haystack. It's very difficult to figure out where the exact error is. The stack trace in JavaScript kind of helps you solve that problem a little bit by saying, "Look, I ran this line, then I ran this line, then I ran this line, and then I got the error." Right, so it gives you a little bit more of ability to put yourself in the shoes of the computer and try to understand how the computer at least navigated to that error. The way that the stack trace shows up is the line closest to the top. So in this case, line 5, that's the latest line of code that ran to get to that error. On line 6, it tells you what triggered that line code, what triggered line 5 to run, and then on line 7, it shows you what triggered line 6 to run. And so the stack trace has the most recent block of code at the very top, and then it works its way down. So it works its way down sequentially. Now, if we look at line 5, I know you guys don't have a lot of context for this particular page of code, but assume that this page of code is called onlyodds.js. That's the name of the file. If we look in that URL on line 5 there on the right hand side, it says localhost 7357. We'll ignore that for now, and then it says onlyodds.js. That tells us which file this error occurred in as the last step before the error actually occurred. And then after the onlyodds.js, notice how there's two numbers after the colons. There's an 11 followed by a 7. Those two numbers are critical because they tell us, the first number tells us which line number the error occurred at, and the second number tells us which character the line error occurred at. Usually people don't care too much about the character number. Once the computer tells you this line is where the error is, most folks can probably take a look at the line and get an intuition for what probably went wrong. But just know that the last line in the stack trace tells you not just the file in which the error was located, but also the line number in which the error was caught. However, one thing to be careful about is just because JavaScript says, "Hey, I came across this error in this line," it doesn't mean the error was caused by that line. An example, that an analogy that maybe could be useful was, let's say there was a car accident and the airbag in the car didn't open up properly. Well, even though the airbag's problem was, even though we kind of captured the error of the we actually captured the error of the airbag at the time of the accident. The cause of the error for the airbag wasn't during the accident. It actually happened in a factory when the airbag was originally being manufactured. And so the point I'm trying to make here is that Just because we see an error being, or we observe an error occurring at a line of code, it doesn't necessarily mean that the error occurred there. It could have occurred somewhere else much earlier in the code, and the impact of it was not recognized, or it wasn't visible until we got to that particular line in the code. Yeah, so the line number is a good place for us to start our investigation, but it may not be the end all be all, as in terms of saying the error is most definitely there. The two most basic error types that you're going to come across, especially when you're first starting off, one is syntax errors, and as the name indicates, syntax errors are very straightforward, right? They're basically typos, mistakes, things that have to do with the syntax that keep your code from running. So whenever you do come across any syntax errors, the two things you should check. The first one is make sure all of your braces, brackets, and parentheses are properly opened and closed. And I can tell you here, if you have a very complex function or you have a very complex piece of code, please indent your code properly. It will make it so much easier for you down the road for you to check and make sure that all of your braces, brackets, and parentheses are indeed open and closed properly. The second thing is make sure all of your commas, semicolons, and arrows are used properly too. We haven't touched on too much upon the syntax of these just yet, but just know that most of these will matter quite a bit. And so when your code doesn't work, you'll usually get an alert saying, "Hey, I expected to see this kind of punctuation here." And so these are the two main types of errors that occur when you see syntax errors. The other common error that you might come across when you're first starting off is something called reference errors. And indeed, that was the error that we saw on the previous slide. Reference errors, in short, just basically means you're trying to use a variable that you don't have permission to use. Now, the reason why you don't have permission to use that variable could be because of issues with the variable's scope. Scope is not something we're talking about too much. Is not going to be something we're talking about too much in this class. But the very short of it is, whenever you create a variable in JavaScript, there is a range of locations on the page where you are able to use that JavaScript code. And so if you try to use that variable outside of that particular scope, then you get a reference errors, or then you get a reference error. However, more often than not, usually when you see a reference error, that's just because you actually probably just misspelled the name of a variable. So imagine if I had a variable named water, water, and then somewhere down the road I try to use the water variable, but I spelled it watr, right? JavaScript at that point isn't smart enough to know, oh, this variable water, he probably meant to say water. It will literally think you're trying to look for a variable called watr. It will look for it, it won't find it, and it will say, hey, you're trying to use a variable that doesn't exist. And so whenever you see a reference variable, just make sure that you spell the name of the variables correctly as well. So a few things, right? The stack trace and these basic error types. Once again, this is by no means even remotely a comprehensive guide to thinking about debugging in JavaScript, but these are places for you to start. And the last thing I'll say here is just whenever you're debugging or fixing code, always make sure you know what's wrong before you start fixing it. I've seen a lot of people not really know what's wrong. They just know that they got an error, and they started fixing things that weren't broken, and then that triggered more errors later on in the code too. Okay, the next topic we'll talk about is something called conditional statements. So far, when we've written code, what we've pretty much done is we've actually just written code that ran sequentially, right? As in, if I run this code 20 times, the same thing will happen 20 times, right? It goes from line 1 all the way in a very linear fashion down to the very end. However, conditional statements are something that we're introducing that actually allows us to control the logic flow in our programs in a much more dynamic and powerful way. Simply speaking, you can think of a conditional statement as a fork in the road, right? Whereas before, whenever we wrote a block of code, every line got run. Now, when we write a block of code, not every part of it is going to be run. In fact, at some point, we're going to make the computer make a choice. Do you want to run this or this? And that decision is going to be based on some bit of information or some kind of data that we either pass it or that materializes in the code. So one of the easiest conditional statements for us to learn is something called the if-else loop or the if-else block. So if you look at the code on the right-hand side here, lines 1 and 2, I just created two variables not really relevant to this code that we're running right here. However, when we start on line 4, notice how I use the if keyword in JavaScript. If and else, once again, just to kind of refresh everyone's memory, if and else are both reserved words in JavaScript, which means that they are part of the language itself, so they cannot be used for naming variables. Now, on line 4, I write the if keyword, and then after the if keyword, I have a parentheses with an expression in between those parentheses. Okay, that parentheses is very critical because basically whatever is in between those parentheses is going to determine one of two things. Am I going to take the if branch in the fork, or am I going to take the else branch in the fork? Okay. If we just skip the true part for now, we'll come back to it in a little bit. What line 4 is saying is if, and then if the thing in between the parentheses is true, then we're going to execute the block of code that follows it. The block of code, the beginning and the end of the block of code is designated by the open and closed curly brace. And in this case, it starts on line 4, ends on line 6, and so the only line of code in between is this line 5, which console logs out, I run this code. On line 7, then, we have the else statement, which says, okay, if you think about just normal colloquial English, right? If I say, if this is true, do this, else do that. The implication is, well, if this is not true, then do this other thing. And that's exactly what the if-else loop does in JavaScript for you too. On line 4, we said, if this condition is true on line 4, do this thing on line 5. Line 7 says, well, if it's not true, do this thing, do my block of code. And by my block of code, I mean the block of code between line 7 and 9, which in this case is mostly contained in line 8, which console logs out, not this code. The most important thing to notice in this if-else loop is just that we are only going to be running either line 5 or line 8. We never run both lines simultaneously, and that's because once again we have a fork in the road. We're making the computer choose one of two different paths. Okay. On line 4, in between those parentheses, just to kind of come back to it, we're going to have something here, and that something inside there is going to take one of two possible values. It's either going to be true or it's going to be false. And later on in this slide, we'll see quite a few examples of how we boil almost anything in JavaScript down to into something that is either true or that is false. So just to drive this point home now, if we kind of look at this in a little bit more graphical format, if you look in the top half of the page on the left-hand side in my block of code, I have my if-else loop, right? In between the parentheses on the if statement, I have if 9 is greater than 8. Well, is that a true statement? Well, we're going to find out, right? But if that statement is true, we're going to console log out this is true. Otherwise, or else, we're going to console log out this is false. And so when we look at the right-hand side, that essentially becomes the fork in the road that we're looking at. I am checking to see if that thing at the very top, if that's a true statement, is 9 greater than 8. If it's true, we're going to console log out this is true. If it's false, we're going to console log out this is false. And obviously, 9 is indeed greater than 8. And so it's true. And so if it's true, we're going to console log out this is true, and we're going to ignore whatever's on the right-hand side, the if not true, or the else part of the if-else loop. Now, a fork in the road, obviously, with two options is simple, right? But obviously, a lot of things in life gets a lot more complex than that. And so JavaScript also has something called the if else loop. In this case, the if part of our loop is still the same. The else part of our loop is still the same. The only difference is in the middle here, we're going to interject this little extra step called the else if. What does this mean? Well, let's actually read through the code and figure it out, right? So if I look at the bottom part of the page on the left-hand side in the block of code here, it says if num is greater than 8, console log out num is greater than 8. That makes sense. Then we have an else if num is greater than 6, console log out num is greater than 6 and less than 8. And so now what we've done is we've actually created almost like a chain of processes, right? The first thing we said is, well, is num greater than 8? If it is, then do this, and then skip the else if, and also skip the else. But if num is not greater than 8, well, let's do the next check, the else if. If num is greater than 6, then print out num is greater than 6. And we know that num has to be less than 8 too, because if it wasn't less than 8, then we would have it would have been captured in the if statement in the very first block. And then finally, if num is not greater than 6, we can confidently console log out num is less than 6. So if you look on the right-hand side in our little diagram or our little tree again, right? We see the same exact kind of scenario play out. In the first fork in the road, we're basically asking, is num greater than 8? If it's true, then we'll console log out num is greater than 8. If it's not true, then we're going to check, well, is num greater than 6? If it's true, we're going to console log out num is greater than 6 and less than 8. If it's not true, we're going to console log out num is less than 6. In any of these scenarios, realize we can only reach one of those endpoints, right? No matter how many times I run this code, no matter what the value of num is, only one of those console logs will ever print out in a single run. And that's the whole point of this if, else loop, is that we're creating multiple conditions, and depending on which conditions are met, the code will do different things. But we can only pick one of these different choices. We never pick more than one. And just as an aside, here we have an if followed by an else if followed by an else. The reality is we can have as many else ifs as we want. So it could be something like, if num is greater than 8, do this. Else if num is greater than 7, do this. Else if num is greater than 6, do this. Else if num is greater than 5, do this. And so on and so forth until we reach our final else. Does this make sense to folks? Any questions so far? Everyone good?
Hi, I don't have a question, but I just was wondering, your audio is breaking up just a little, and I wondered if there's anything you can do.
Sorry about that. Is it better now? I can try to sit closer to the mic.
Yeah, that's better.
Okay, great. Sorry for that.
Thank you.
Okay, so now we've covered so far kind of how the flow of the logic is going to go, right? We're creating multiple conditions, and depending on which condition is being met, it takes us to a different part of the code to run. Well, the last thing we're going to talk about then is just, okay, how do we know, or what does it mean for a condition to be met? And so here's where we actually come back to our friend the Booleans. But before we even get there, we want to talk about like kind of comparisons, right? Because if I think about it, like really want to ask you is this condition met? The answer is going to be a yes or no, right? Either the condition is met or the condition is not met. Remember, computers don't deal in ambiguities. Either something is yes or something is no. And so a very common way to figure out if a condition is met is to do a comparison, right? Is this value equal to or greater than or less than this other value? And so we'll just do a quick crash course in the comparison operators. Hopefully they're pretty simple. The way to check if two values are equal in JavaScript is to use the 3 equal signs, the triple equals. Okay, very, very important that you use triple equals. Remember, single equal or a single equal in JavaScript is not a comparison operator, right? If I do let x equal 6, I'm not comparing x to 6. I am assigning the value of 6 to x, and so therefore, when we think about comparison operators, always make sure that you're using triple equals if you're comparing two values. A single equal is an assignment operator, not a comparison operator. The other thing to check out so then the opposite of that would be to check if two values are not equal, and to do that we use this exclamation mark equal sign equal sign. We'll talk about the exclamation mark in just a little bit in a later slide, but the proper terminology for it is called a bang operator, B-A-N-G, and a bang operator, exclamation mark equals, basically means are these two values not equal? If they're not equal, then the value is going to be true. If they are equal, then the value is going to be false. And aside from those two, we have a few more operators that hopefully look a little bit familiar, at least based on kind of what we probably did in math class in either elementary school or high school. Essentially, it's like greater than or equal to, less than or equal to. Those four, I think, hopefully should be pretty straightforward for most folks. But yeah, between these 6 operators, we have ways to check for equality, to check for inequality, check for less than and greater than, and also check for less than or equal to or greater than or equal to. Okay, so now that we know how to check and compare values, the last thing becomes, okay, well, how do I actually know if something is, remember, when I have these conditional statements, when I have an if clause or whatever, or what have you, my whole goal is to know is this true or not, right? If it's true, I'll do this. If it's not, I'll do this other thing. And in that kind of a black and white world, everything has to either be true or not true. right? And so that takes us back to our discussion on Wednesday about booleans. Remember, booleans only have two possible values. Booleans are either true or false. There's no middle ground. And so often when we talk about a value in JavaScript about whether or not it's truthy or falsy, what we're really asking is, hey, if I take this variable, or sorry, if I take this value and I convert it into a Boolean value, is it going to be a true value or is it going to be a false value? And the truth is, in Java, sorry, no pun intended, and the reality is, in JavaScript, in most cases, most values are truthy or truth-like. And what that means is, when I convert most values in JavaScript into a Boolean value, I get back true. So, and don't worry too much about the casting of a booleans for now. I just notice that I am a string is in Boolean land that is technically true. The number 10, that is true. Any array, any objects are all true, even if they're empty. Okay. There's a lot of possible true values in JavaScript. So usually the way that we determine what's true or not is by remembering the false values. And everything that's not false is therefore, by definition, true. And so when we think about falsy values, or values that are false when we convert them to JavaScript, there are only a handful, which makes them pretty easy to remember. When it comes to strings, the only false string is an empty string. Any other string with any other value inside of it is going to give you a true value. The only false string is an empty string. Similarly, there are two possible false values for numbers. The first one is 0. If a number is 0 and I convert it into a Boolean, that's technically false. Nulls are false, undefined are false, and the other number is actually this thing called not a number. Don't worry too much about it for now. Just know that not a number usually happens when we try to do mathematical operations on things that aren't numbers. Essentially, it's almost like an error value of sorts. That's also false as well. And so when we think about falsy values in JavaScript, these are the only 5 falsy values, 6 if we include false itself. So just to reiterate, the only falsy values in JavaScript are the empty string, the number 0, nulls, undefined, not a numbers, and false itself. So then this goes back to our bang operator, right? The bang operator is also sometimes called a not operator. And the reason why is because it basically takes something and then converts to a Boolean, but gives you the opposite Boolean of what the value truly is. So here on line 4, I have a value called true. Well, true value is true, right? But when I put an exclamation mark or when I put a bang in front of it, that now gives me back a false. Similarly, on line 6, I have a string ABC. That's true because the string has characters in it. But as soon as I put a bang in front of it, this is going to give me back a false. Same for 100, same for an array, same for any object, right? These are all inherently true values, but when I put an exclamation mark, when I put a bang in front of it, it gives me the opposite Boolean value of that value. And so the opposite of any truthy value is therefore false. Everyone with me so far still? Pam, can you also hear me better now?
Yes, thanks.
No problem. Okay, so if the bang operator is something that gives you the opposite Boolean, well then we have something called the double bang operator. Double bang operator is obviously like the not because it's the opposite of the opposite. But if you think about it that way, it can actually probably drive you crazy because it's actually really just counterintuitive and really difficult to rationalize through. So the way to think about a double bang operator is just saying, what Boolean value is this, right? Because one bang converts to the opposite Boolean value, while two bangs going to convert you to the opposite of the opposite, which takes you back to the original, right? So you can almost think of a double bang as saying, just, hey, what is the Boolean value of this value? So the Boolean value of a true is still true. The Boolean value of the string ABC is a truthy value. Same for 100, same for an array, and same for an object. So whereas one bang gives you the opposite, two bangs gives you the original or the proper Boolean value of a given variable or a given value. Okay. The last two things we're going to talk about today then are going to be something that allows us to compare multiple things at once. And these are something called the AND and the OR operators. We'll start with the AND operator. We write the AND operator as a double ampersand. And the way that the double ampersand works is, think about it. Think if I'm trying to bake a cake, right? And I send you to the grocery store with a list. Well, and I tell you, hey, I need eggs and milk and flour. Okay, it's very imperative that you come back to me with all three things, because if you only come back to me with two of those three things, I cannot bake a cake, right? And so what and does is and is saying, well, I need to make sure everything that is being checked is truthy or true, right? Because if it is, then I can execute it. If it's not, then this list is incomplete. And so here on line 4, here's an example of how we would use like a and operator. And checks from left to right. And so if I was the computer, here the first thing I would do is I would check I would create the variable return value, and the value of it, if I started from the right hand side of the equal sign, is I will start at 10 and say, is that truthy? And the answer is yep, it's truthy. Great. Then I'll go to the next value, the string apples. Is that truthy? And the answer is yep, it's truthy. Great. So I'll go to the next value, number 0. Is that truthy? And the answer is no, it's not truthy. And that's where the and operator is going to stop. It's not even going to check the no, because it knows that, well, in order for this list to be true, everything in it has to be true. And I've already encountered at least one false, so I can tell you definitively that this list is going to be false. Okay, and so that's an example of where the and operator will give you back the first false value that it finds. However, if it goes through the entire list and finds no false values, then it will return back the last value that it looked at, which is by definition going to be a truthy value. So if you look at line 7 here, the first thing it checks is a string lucky. And then the next thing, which is true, the next thing it checks is a string number, which is also true. And the next thing it's going to check is a number 7, which is also true. And then it finished it. And then we're done. Right? And so once again, the and operator operates kind of in a sequential format where it will check a list of things and it will return back either the first falsy value that it finds, or it will give you back the last truthy value if everything in the list is truthy. And because it goes sequentially, it will always stop at the first falsy value, right? So if you have multiple false values, it doesn't matter. It will find the first one and say, here it is. I'm not going to bother checking the rest. Just like how if I send you to the store with 3 ingredients to buy cake, and you came back saying, hey, I'm missing milk. I don't care what else you bought because we don't have enough things to make the cake with. So then the opposite of the and operator is the or operator. Those two vertical lines that we're using for the operators, those are called pipe symbols. A pipe symbol usually on your keyboard is located beneath the backspace or the delete key. And so if you think about the or operator, right? If I send you to the grocery store and say, hey, I'm really thirsty, can you give me something to drink? Can you give me a Coke or a water or a Sprite? Well, the idea is you can give me any of those 3 values and it's going to be fine. And so what the or operator is looking for is looking for the first truthy value. The first match it finds, it says, great, I'm good, I'm done here. Or if it goes through the entire list and finds no truthy values, it will give you back the last falsy value. So in that way, it's almost like the mirror opposite of the and operator. So here on line 4, if I walk through this or operator process, the first thing I check is the null value, which is that truthy? No, it's not. So I jump to and check the next value. Is undefined truthy? No, it's not. Okay, let me check the next value. Is the string happy truthy? It is. And at that point in time, the or operator says, great, I don't even need to check the 4th value because I've found at least one value that works for me. Similarly, on line 7, and if I do the same process, I go from the false value at first, which is falsy, obviously. Then I go to the next value, which is null, and that's also falsy. So then I go to the next value, which is checks, is 10 less than 0? Well, 10 is not less than 0, so it's falsy. And then lastly, it's not a number. Is that falsy? Yeah, it's falsy. Great. So there's no true values in this chain. So I'm going to give you back the last false value. And so therefore, when I return back in the first example, I give you back happy, which is the first true value. And the last example, I gave you back non-number, which is the last false value. Okay. Like I said, it's a pretty dense stuff. And when you do the workshops today, there would be a lot of times where you have to talk through and rationalize it with your partner, and it's going to be a little bit confusing. So just be patient and keep at it. But before we separate, are there any questions?